Crowd of the periphery crowd, I'm going to call you folks. You're all hanging on the edge, which is kind of interesting. Good thing you're not late for church. You have to sit up front. But anyway, my name is Pete Vanderstappen. I'm the acting estate engineer in Pennsylvania. My background is I was born on raised on a dairy farm in western PA. I think my dad milked 40 cows. A DC came to my office at my dad's farm. He was a district conservationist or on the board. And the guy said, what are you doing for work? And he said, I said, well, going ag engineering. He said, well, Soil Conservation Service has a student trainee program. And I made a bunch of phone calls in my junior year, and I got on with Virginia as a student trainee. And that was my start with SCS 40-some years ago. Anyway, since then, I've worked at Virginia a couple years, been in Pennsylvania for the balance of that time. I spent 3 years doing dam construction, but the rest of the time has been an O1 type work, mainly manure storage systems. And in the early 90s, I hooked up with Pete Wright, the retired state engineer from up in New York State. And we did some silage leachate presentations back then. And I guess that's my name to fame. At least you Google my name, you'll come up with these presentations back in 1994 or something. Anyway, so I've had a lot of experience with silage leachate collection, the Pennsylvania way of doing things. And we'll start with that. So we're going to take a look at why silage leachate is an environmental concern, what these systems present for planning and engineering, why they are challenging. They think it works now, okay. The common strategies for all systems. We're going to look at some typical BMPs that we use or different methods. Example installations at various locations. Talk a little bit about O&M and we'll wrap it up here. If you have any questions at any time, you can jump in, no problem. So concerns, why we're concerned about this stuff. You know, silage leachate, typical nitrogen is 44 parts per million. Nitrogen's pretty hot stuff. And you look at here, the really big one here is BOD, 12,000, 90,000 milligrams per liter. If that's concentrated juice, a gallon of that will contaminate 10,000 gallons of river water and basically suck the oxygen out to the level that fish won't survive. And you know, the challenge with silage leachate, typically in Pennsylvania, most of the harvesting is done in the fall. Stream flow is low. If you have any juice coming out there and makes it to the stream, your solution to pollution is dilution. In this particular case, it's not. It's going to have a fish kill. So it's pretty nasty stuff. Along with a low, the pH is here 3.5 to 5.5. It's low pH. So what generally they think about the production period of how this is produced. It goes over, this is a typical cycle here, a bell curve, it's from 0 to 30 days. So if this room is a bunk silo and you filled it, the juice will start happening probably about day 5 to 7 is when you're going to have the peak flow. And then it'll keep going for about 30 days and kind of run out to nothing. So at a typical harvest percentage, you'll have about 30 days of discharge and then it'll basically quit. What causes the flow, it depends on, the yield is typically for design, we usually use 7.5 gallons per wet ton, harvested at 75% moisture, but that depends on what kind of crop. 40 to 7% range. It depends on your crop type, what moisture range you'll get the actual juicing to go. I've estimated too that the typical peak rate is 1 gallon per ton per day. Even though we only have 7.5 gallons over 30 days, that peak could be about 1 gallon per ton per day. And I kind of use that number as a guidance if you want a daily haul. Say, I'm going to haul this stuff, and we'll show examples that you need to think about, gee, I have 1,000 tons, I might need 1,000 gallon storage there to haul it if I'm going to haul it every day for a couple days. Production rate, just back to the same thing, this is the idea that 7.5 gallons per ton is a design tool, a number to start with. There's so many other variables out there to go with, but certainly if we're designing a system, we have to collect it. That's kind of a number we could use for the storage, or the storage capacity. Here's a typical example in a small situation. Pennsylvania is kind of unique. We still have 7,500 dairies. So there's 7,500 opportunities to have probably some sort of a bunk system or some sort of silage collection system on the farm. And this is a typical one. Kind of, you notice here that the cases, looks like there's vegetation here, but now it's brown. So they did a successful planting here, but all of a sudden it's dead. And that comes back to the idea that probably maybe for a year or two he had no leachate, and then all of a sudden one year he harvests too wet, and then he had leachate coming down through and you get a vegetative kill. If that would happen every year, you wouldn't even have the roots here. It'd be a ditch, just a dirt ditch. But the other thing we always run into, and these are the ones we get more calls on, is the larger bunk complexes, half acre, 1 acre, 2 acre sites. You got a lot of spoilage here. You get a rainfall event, you get a bunch of runoff. And then different site. I had just happened to be at this site 2 weeks ago. There's the actual discharge point, but look at this nasty stuff out in here. So all the low flow went out, along with the high flow, laid on the surface here, killing vegetation. And it's been going on for a while. This wasn't day one. And we're in the process of revamping this entire site. But certainly a challenge. The other thing I want to mention at least once is the concept of leachate. That's that pure juice that comes out of the first process of the ensilage process. But the second one that's just semi-bad but causes problems is percolate. And percolate, you fill a bunk silo complex, fill it very full, cover it right away. The silage starts settling, the water comes on the edge, there's holes in the plastic. The rainwater comes along the side and percolates down through the haunches here, and then eventually comes out. So it's a sunny day today, it rains all day, you don't notice anything. 2 or 3 days later, sun's out again, and all of a sudden a day or two later you'll see this tea water coming out. So it's not as concentrated as the original leachate, but certainly is not the water you want to be drinking or nor running straight to a grass area. You need to collect this low flow percolate also. Design challenges, the biggest one, most locations we run into, no one ever thought about this stuff. So it's wasteland. Areas they didn't want to use, or it's low areas, it's near the dairy complex, but it's not really a good site. So you're stuck. Farmers got a mentality, here's where it is, I got to address it right here. The other challenge is regulations vary by state and agency even. NRCS in Pennsylvania, we treat the high flow to a grass area and we want it to be spread out very wide. So we're trying to spread this stuff out 100 feet wide with a spreader pipe or something and spread it out wide to go down through the grass area. That's for our stormwater. New York State took a different approach. They take the high flow, same thing, but they use a small channel, like a 20-foot channel, and they want to go 600-700 feet long in a more of a filter channel. Two different ways. Outcomes probably very similar, but just different ways of addressing that resource concern. We try to come up with practical solutions, but when they're practical solutions, they're not bulletproof, and O&M is a critical thing to make them happen the right way. We're always dealing with the issue of floatable solids blocking our systems up. We're trying to collect 2 or 3 or 4 or 5 gallons per minute, and it doesn't take much to plug up that kind of system. So we're always dealing with that. And the other thing we run into is, as these systems get bigger, catching low flow, even if you're only catching 5 gallons a minute or 10 gallons a minute, you're catching all the juice, which is great on a sunny day. We're just catching that leachate. But when it's raining for 2 days straight, you're also catching 5 or 10 gallons a minute also. That adds up to be a lot of water over a typical rainfall season in Pennsylvania. So that's another challenge we're trying to address by limiting the collection of low flow during the rainfall events. Bunk silos vary all the time. Some guys have one bunk, it's pretty easy to do. Other ones have multiple bunks, or they have multiple crops they harvest, so it's all over the place. We're still trying to avoid collecting rainfall. Spoiled silage, that's another issue we run into. If they have waste materials on that site, we want them to be removed, or they don't remove them, and those little piles of silage leachate generate this percolate stuff. It can regenerate stuff too when it gets wet, so that's another problem. A lot of times bunk silos are located to other commodities. So you have a bunk silo complex that faces a commodity shed. There's a big concrete area in between. It's already there. Now we're collecting not only the leachate, but we're also collecting more stormwater. So it kind of just exasperates the design process. Snowfall cleanup. It does snow in Pennsylvania. Maybe not in Maryland, Delaware as much, but certainly when it snows a foot or two, they end up cleaning that stuff up. And there was a case in New York State many years ago. They were cleaning up their bunk silo complex all the time, dumping it in one spot. Well, over the winter, over that time period, they accumulated a lot of silage in that process. When the spring came, all the snow melts, it had a pretty good sized pile of silage left over, and that material is really super wet. It started leaching out, and it was next to a stream, and they had a fish kill. So that secondary percolate ended up causing a fish kill. Not the main bunk, but the secondary pile. So you got to be careful where you pile up your waste materials. Put it in the manure storage, put the manure spreader and spread it. Do something with it. Common strategies for all systems. Solids got to be contained and separated. That's floatable solids, those kind of things. We need to somehow have settling areas or something to screen that out. We always want to capture the low flow. That's the critical thing. And we're either going to send it to an open-top manure storage, and that someone asked a question in the first session. We don't take silage leachate and pump it into an underground or a covered storage. There's concern about hydrogen sulfide generation, a couple other things. So if this was a storage pit underneath the barn, we would not pump the leachate into this pit. We want an outside pit. We don't want any possibility of generating gases and stuff because of our leachate. So either go to a storage, we can collect and transfer to the storage, or we can haul with dilution. And we'll talk about a couple examples of you can capture the pure leachate and do some dilution and actually spread that. The other side of the story is the high flow or stormwater. It's got to be redirected. We are not running the stormwater straight to the stream. We still want to go through. In Pennsylvania, we go to a grassed area, under hayland planting, I guess. In some states, they may call that a VTA, vegetative treatment area. And the distinction between a grassed area and a VTA has a VTA, vegetative treatment area. The size is based on some nutrient load you're getting from whatever you're treating, typically barnyard runoff. We're saying basically in a high flow situation, there are some nutrients there, but it's very low. So as long as you go through a grassed area before it gets to the stream or whatever, we're very comfortable that's never going to cause a problem. All problems are coming back to this low flow stuff that causes fish kills and vegetative damage, those kind of things. And then, some states have other multiple redistribution systems. So different states have different rules. I'm going to touch on this one page here. Just kind of an idea. This whole idea of we're catching low flow, that's all great, 5 gallons a minute. The other challenge is, statistically, I don't show it all here, but statistically, you're going to have several thousand or maybe a couple thousand hours of rainfall in a given year. Well, at 4 or 5 or 10 gallons per minute, that's a lot of water you're collecting that you shouldn't need to collect. And we're trying to work on different processes to come up with a number. If you have to collect it, here's how much more storage you would need. And if you don't have to collect it, what can we do? So just an interesting concept of trying to cut off that low flow collection during high flow rainfall events. And we'll talk about a couple different ways of doing that. So for large bunk silos, obviously one choice is we could actually close the pipe. You have a large flow. If it starts raining, the guy can manually go out there and close that low flow pipe. But folks, what does that mean? We're relying on the landowner to come back and remember to open it back up. So the one thing we've been promoting, I think one farmer's done it so far, you can buy a rain sensor. It's a glass device. When rainfall hits it, it senses it. And if you have a control box there, it can say, okay, it starts sensing rainfall. Every 10 minutes it checks, it's still raining, it's still raining. Now it says it's raining for 20 minutes. You can tell it to go actuate something to close your valve. So your low flow valve gets closed. So the initial flush coming off the silo when it starts raining still goes to your low flow collection, but then it shuts that valve off and everything becomes high flow. So that's one way of controlling that. And this rain sensor sits out there, and if it keeps raining every 20 minutes, it keeps the valve shut. Then when it quits raining for maybe an hour or 2 hours, whatever you set it up to be, now notice it's not raining anymore, it opens the valve back up. So that's one way of doing that. The other one is if the low flow is pumped, we can actually turn that pump off. And we've had some cases where we're taking high flow and low flow into one tank. And we'll have a little wee pump in there that can only do 5 gallons a minute. That's pumping to storage. Well, as soon as that pump gets to the high flow level or alarm level, the other pump's already kicked on and go to your high flow system. You could have, this pump could be turned off. The low flow pump could actually be turned off. So you're not pumping that extra 10 gallons a minute over to your storage. Doesn't sound like much, but over a year, that's a lot of water. And I did the math one time. For the $1,000 it takes to set up one of these systems, you'll pay for it in a year. So that's a pretty good benefit to the landowner to haul less material. Every gallon of waste is another penny or so. Small bunks, a lot of times, single bunk system, they have one pile of material there. It's harvested right. You get very little juice, or the juice quits after 30 days or less. They just close the valve off. They don't have to worry about it. They're not having a low flow discharge anymore. They don't need to collect it. So that can be an option. But again, anytime you have a physical closing and opening, someone's got to remember to do that, and that's always a challenge. It is a high risk. And maybe from the regulatory sites, they won't allow that. But certainly it's an opportunity on smaller operations. Potential treatment options, it always starts with prevent or minimize. You know, let's prevent the juice from starting, that's the big thing. And that means harvesting somewhere between 40 and 65% for the silage, depending on what kind of crop, whether it's rye or corn or haylage or whatever. That's a critical thing. Harvest it at the lowest possible moisture you can to minimize or prevent any percolate from coming out. Good bunk management, keeping the site clean, getting rid of the, dirt, the waste materials, and complete covering. Proper covering of the bunk keeps all that rainwater from coming onto the site and percolating down through. If you don't have a waste storage facility, so you have no waste storage facility at the site, you can collect and haul as needed with a 50% dilution prior to direct land application. We showed examples of that. So if you're going to collect this leachate, it's low in pH, high in BOD, you just can't spread it on land, it's going to kill stuff. So you need to dilute it by 50%. Most landowners, they'll fill up their tanker with a half a load of manure, then top it off with another, finish the 50% off with their leachate they collected that day out of a tank. The other choice, we've seen a couple cases. I did an Amish guy one time. We actually had well water coming into a tank, and we had a float valve on it. So basically, a 1,000-gallon tank, we had well water coming in, filling the tank, put 500 gallons of clean water in. When the juice started coming out of the silo, when it topped off at 1,000 gallons, then it would dose to a spreader system. So we got that 50% dilution to do some treatment on it before it went out. And we had another guy years ago, he actually had a pond. So we actually had a pond, a good water supply. We dumped pond water into the tank, fill it half full, and when it got finished filling the tank, we could also dump at that point in time. So a couple ways of diluting it. Number one, the last one that's pretty rare, never used, but you can collect and treat with hydrated lime. Takes about, this is old school, but 22 pounds of hydrated lime per 260 gallons of wastewater. Never seen anybody do it, but it could be done. Probably pretty expensive, very intensive. So that's without storage. If you have a storage, that's the cat's meow. We can collect the low flow and go to the storage and direct the high flow to a grass area or VTA as per state regulations. The other factor we got to keep in mind all the time is leachate will happen. I go out to the farm and say, oh, I never have leachate. Well, maybe that particular year he doesn't, but there's, weather can force premature harvest. The custom hauler or the custom operator that's harvesting your crop shows up 5 days early. He's got to get it done today or you don't get it done. So he's going to harvest regardless of moisture. They aren't keeping track of the moisture, paying attention. The other thing is the storage facility is poorly designed, has cracks, so even if they have leachate, they can't collect it all. It goes down through the floor, goes up the sidewalls, just a bunch of issues. And like I said, if not this year, next year. So typically, somewhere down the road on that farm, you're going to generate leachate and you need to deal with it. The typical cadre of practices we use is waste transfer, and that's where, in the waste transfer standard, is where Pennsylvania keeps its starting guidance on silage leachate collection. You go to the waste transfer spec. But you have pumping plant, waste storage, structure for water control, heavy use area, filter area, VTA, haylage planting, critical. These are all a combination of acronyms or practices we use to generate a system to properly collect and treat and handle silage leachate. So where are the sources? Typically vertical silos, all different shapes, airtight, concrete, wooden, whatever. Ag bags could be on earth, some are on concrete. And then the last one is bunk silos, concrete lines, sometimes earthen. They could be above ground, covered piles, all kinds of different ways. So we're going to look at each one of these different systems and look at some different options we've used to handle the leachate on them. So vertical silos to me are the easiest one to collect. A lot of times, most have roofs on these days, so that's a good thing. If they don't have a roof on, that's another problem. Then you get all the rainwater that keeps percolating down through. Most have roofs on. Typically, only have one discharge point. They usually have a pipe somewhere. They have a drain down there somewhere, pops out. And if they don't, or in a lot of cases, it might come into the bunk silo room. If it actually comes into the bunk silo room, a lot of times it'll flow right across the alleyway, right into the gutter and go out down the waste storage system. So not a big problem. Typical solutions are, we just collect a small collection box. Here's a pump, here's a pit or whatever, pipe it in the collection box and we'll pump that to the storage or gravity flow. Sometimes we don't have a defined pipe. We just know there's juice around the perimeter of the tank. We'll dig a trench, put a pipe in it, backfill it with stone, and just kind of collect whatever we can collect there. Some system to collect the juice coming out of that tank, or out of that particular vertical silo. A couple examples here. I was just at this one the other week. So here's your vertical silo, kind of juicy stuff here. They actually ended up digging a trench along here and putting a pipe in it and goes to, there's a box underneath here, and there is a pipe that goes underneath the barn, and I'll show you the outlet here in a minute or so. But so we're just randomly collecting juice from wherever and piping it over to this here. You notice also that we are collecting some storm water. So we have a combination of subsurface juice collection and some storm water. But here again, we're adapting to an existing site, and we have a pipe that goes under the barn. So we have a way to carry it one other place. Another example, different site, vertical silo, and we have a point discharge here. In this particular one, we'd actually put a box in here, put a little pump in here, and I'd pump it to the storage. So that on the previous page, this is the pipe at the other end, coming up from underneath the barn, and they have this an overshot just a little bit. And here's your vertical pipe, a 4-inch pipe that actually goes to a small tank, and then you pump from there. But during low flow, low juice periods, it just drops out of the end of the pipe and drops down, and we collect the low flow that way. When it starts raining, if we get any kind of rainfall, it actually overshoots out, and most of the water, most I say, will shoot out over that and go out as a high flow situation. A lot of times we'll take the collar of this pipe, and this is a pretty big one. We're retrofitting existing pipe. But if this would be a 6-inch pipe, we'd actually make the collar adjustable. It can slip in and out a little bit, so we can kind of tweak it if we need to slide it in and out. Or I've seen guys put a 1-inch hole in the bottom of the thing and drop it down. All kinds of different strategies to really minimize that low flow collection. We want to collect low flow, but we don't want to catch the high flow. Because just extra water going to storage and extra material you have to process. More examples. Now here's a vertical silo system. They had a drain. They went over here. I think this site was a drain that went to a road ditch. Well, we cut that drain off to the road ditch, put a vertical pipe in here and a small pump, and now they could pump it to the storage. In this particular one, they only put the pump in there during the leachate season, which for vertical silos, at 30 days, they can pump it out, and when it gets too full, it pops out the top. They know they got to get started on pumping. Another example, here's a bunk silo system. They have a pipe here. There's probably a 1-inch hole next to this pipe. That's it. And here's another example where they just extended the pipe right into the storage. So, multiple ways of trying to capture low flow. We did talk about the concept of haul as needed method. And this particular farmer, the story was we were working with this farmer. He was a demo site for, we have a boot camp every year. And we had using this particular farm for a boot camp farm, training new employees to say, here's screw-ups and how are we going to fix them. Well, this farmer, I don't have a picture here, but he had all these vertical silos. He had 3-point discharges. There were 3 dead zones that were probably 150 feet long, 25 feet wide, right to the stream. And pretty easy to identify we had a problem. We talked about solutions for training. But the farmer had never implemented anything yet. Well, on a Sunday morning, grandma and a grandson downstream, a quarter mile or whatever, they went down the stream, and it was nasty water and smelly and dead little fishies and whatever. They called DEP up. DEP came out the next, or Monday morning, Tuesday, whenever they came out. They walked upstream, and here's bunk silos over here, and there's dead grass coming here, and you can see the juice dropping right into the stream. So our person worked with him, and at that time he didn't want to pump. He didn't have he had a storage, but he didn't want to use it. But anyway, bottom line was we put a multiple system of collection pipes, and here's one we collected the pipe right at the end of the tank. But we collected all the runoff and went to an underground storage tank. And then this device here with that thing on there, there's actually your kid's floating noodle. We have one of those down here glued to the stem, so when the tank gets full, the noodle floats up and pushes this bulb up so the landowner knows it's time to haul. So when this noodle starts going up, he knows he needs to haul. And he knows, too, that when he fills a silo, you're going to get juice for the next couple of weeks. So that worked pretty good, and that's one way of doing it. But it takes a lot of O&M from the landowner to get out there and keep pumping this, pumping it out for the next couple of weeks till it quits discharging. And that's all good until he fills the next silo up and has to start the whole process over again. So it's a repeating occurrence. Ag bags are common for silage storage. Typically, they're either earthen sites. They might have some permanent sites. Grassed area, they use the same spot every year. Still requires diligent O&M. And I estimate, a lot of ag bags might discharge. They're 300 feet long, maybe 1,000 gallons. But it depends on what the harvest moisture is at the time of harvesting. all those kind of things. Concrete sites are a little better. Some farmers realize that they have an issue with E&S control on these sites. Every time you clean the ag bag up, you have all this dirt. They want quality feed. So what they'll do is they'll concrete the whole area. So we'll have a humongous concrete pad with a bunch of ag bags on it. And very stable. There's no E&S issues. And then what we typically look at is some sort of low flow collection system to a temporary holding tank and pump that to storage. And we try to get the high flow to go to a grassed area. And sometimes a combination of things. I have some pictures here to show you on that. So here's an ag bag, typical. It's probably using the same site every year, but everything gets tore up. Maybe he comes back in the fall after he empties it out, he actually seeds the area again. But right there we have that, this isn't sealed that well, so he has a discharge starting right away. Sometimes they seal them up pretty good. You can kick the side of it, and you can hear the water in there. Not until you take that knife and cut it open do you get that 500 gallons or 1,000 gallons coming at the end. But here again, we take a look at where this is located and what kind of effect that's going to have. Certainly an opportunity to do something. The more typical situation right here, ag bag, do a concrete area here, and here again there's a pipe. You can't barely see it, but there's a little pipe sticking out there. So the low flow comes out that pipe and drops down the pipe and goes to storage or collection, and the high flow shoots over it, or if it really gets bad, just shoots over the whole thing. Here's another example, pretty simple system. This is like a 4 or 5 or 6 inch depression. We probably put the collar of a pipe here, put a stand pipe with a couple holes in it. We don't have to worry about settling solids out on these ag bag systems. That's typically not a problem. But here, the juice comes here. We can easily handle a couple gallons a minute if he does have juice. But as soon as it rains, the runoff water will overtop this whole thing and go to a grassed area. Pretty straightforward, very simple system, but we can catch that low flow. That's our goal. The other one we've seen, the sound looks really good. 2 big ag bags. I think these are 150 footers. But anyway, snow and whatever. But nice grassed area. It looks pretty good. But if I didn't take the other picture, turn around is like 30 feet away from a stream. So and it's on a slope. So this area, if there was 1,000 gallons here, cut that open. Will it get to the stream? I'm not sure. So we talked to the landowner. This isn't a good site because if you'd come here in the spring after he tore these both open, this all becomes, there's no vegetation here. This gets all tore up pretty nasty. So he moved it up to the other, uphill to another site. But we run the same problem. We hit a ditch over there. So he got away from the main stream, but now we're near a ditch. And the ditch is going to do the same thing. It's eventually going to get to the stream. So always a challenge to get these sited in the right location. Bunk silo in ground, I think these are the more difficult ones. Might have subsurface water flowing into them. So they might need a perimeter drain. Who knows what they're sited on? This is a farmer needs a bunk silo quick, doesn't want to put sides up, dig a trench back into the hillside. Pretty straightforward. If it's pervious soils, we need to put a drain underneath of it. Maybe you have to resurface with concrete. They don't have any, or even the slopes. I'll show you some pictures of that. Collect the low flow and properly handle the high flow is always what we want to do in the end. In some situations, relocating. Yes, we're going to move something, folks. Relocating the entire facility and decommissioning may be the best solution. We do a lot of farm sites where the good old days was the barn was built near the stream and everything's near the stream. A D8 dozer would be the best solution to start over and move up the hill. But anyway, so here's an example. Back to this, bunk management at its worst. You get these situations you run into still that the guys aren't managing it all, and the groundwater got into here, and surface water and everything else. Not only his leachate coming up, he probably lost all his material anyway. A lot of waste of good forage. A couple examples. Here's a bunk silo, the hurry up quick deal. I need bunk storage. Dig back in the hillside, dig it out. He did put concrete in the bottom, but you still have earthen slopes on the side. Here's another little one too. Put some concrete in there, but this was a road ditch. So if you harvested too wet, the juice got here, and the farmer got a complaint. We looked at it, and he decided he was not going to use this bunk silo anymore. That was a good solution. Now here we do have one up. It's up on top of a hill. He does have concrete. Looks like he didn't scour out the edges too bad. We put a concrete apron there, and we have this, maybe a 6-inch rise in here and several pipes and holes. So if there's juice coming out of here, we can handle that low flow. It flows, I think this went gravity under the road to the storage, but the high flow goes through a grassed area. Above ground pile, sometimes they have surplus forage for a year or two. the farmer's expanding, whatever. This is kind of the transition, or they have vertical silos, now they're going to start transitioning to bunks, and they don't build anything yet. They'll just pile it on the surface. It's easy to implement, but they got to take a look at where they're at and location. And we'll talk about this. The other one we'll talk more common is a bunk silo above ground with panels. That's typically anybody over 200 cows or more is going to go to a bunk silo complex with either vertical walls or concrete slope walls. But here again, they locate them near surface water. They're not liquid tight. They have either joints in there or they put concrete that's 4 inches thick and can't take the abuse of a 50,000-pound loader anymore. So the concrete breaks up. So if you get juice in the pile, it doesn't make it out to the end, it just goes straight down. They don't cover it correctly. And of course, the larger the size, the more volume you're going to get, and they have poor management. The other thing, we've had a couple sites on these existing sites, the farmer knew the site was wet. So before he built the bunk complex, he put drain tiles underneath it. Then he built his bunk, put concrete on everything else. Well, you got cracks. So the juice now goes down into these drain tiles. It becomes a direct discharge of somewhere. So we get in there and said, now we have to collect, not only collect the leachate coming out of these pipes, we also collect the groundwater because it's probably not sited in the right location. Another challenge. We want to divert off-site waters always, collect at the entrance. Our goal is, we're not in the building bunk silo complex. We certainly want to collect typical one end. But we're going to do the same thing, collect the low flow. I had a case with DEP. They had cracks and stuff, so the solution was, consultant was working on this project. They went through the entire bunk complex and tried to patch all the cracks and joints to minimize leachate going down. And then we had to collect all the runoff. It was next to a stream. Literally, the bunk silo was here and the stream was 25 feet away. So it was a CAFO. So they had to control up to the 25-year storm off that bunk silo complex. So, worst case scenario is the bunk has 5 days of forage. It's 95% empty. You have to collect 6 inches of runoff and not let it discharge into the stream. So you're collecting low flow, but the high flow, you have to trap it, catch it, do whatever you want with it. Then you have to pump it somewhere else. That becomes pretty challenging. Here's Silage Leachate. This is a pretty good site. Let's back up here. This particular operation, he did that. And a couple years later, we went back and he actually built a bunk silo up on top of the hill with vertical walls. And I looked at the joints. We talked about getting them sealed up and stuff. But he had no collection system on the end of it. No system to catch low flow. Now, this particular farm was, 2,000 feet away from anything. And I went back there several years later, or several years I go back there for training, and it wasn't until year 3 that he actually had juice. First 2 years, he harvests his own material, so he controls his harvest. That's good. So he can put it in at the right moisture. But year 3 or 4, he had asphalt driveway coming out of this thing, and there was a wet spot in his asphalt driveway. So juice was coming down through a crack somewhere and finally made it to the surface. And we talked about collecting that. But I tried to warn him, but like I said, sooner or later you'll have juice. A couple different other just examples of some minor systems we put in the past. Here's a low flow system coming off here. Yeah, why is the tire there? Well, that's a farmer solution. This pipe, it probably is a 1-inch opening in the side of the pipe, and that's it. We're trying to only capture. You got maybe 6, 8, 10 inches of head here. So if it starts raining, you can put a lot of water down that pipe. It was open 4 inches. We only want 5 gallons a minute or less. So he put this tire around there. So most of the time, any floatables that come down there will move around the outside, and the juice can still go underneath the floatables and make it out. Farmer solution, works great, high maintenance. The other thing we always do too, so we have tanks for pumping. We certainly want some sort of a light and alarm system in case that pump fails. We want to make sure the landowner is aware of that, so he goes out and fixes it. We don't want this. The engineers are always embarrassed when we come out there and there's juice floating out of the top of the lid here because the farmer didn't empty it. So we want to make sure the landowner has a chance at making it work right. A couple different examples we'll go through. There's a very large complex on a 1,500 cow dairy, and the solution of that particular site was they put a big diversion on the low side here so they could collect probably up to the 25-year storm. It all runs the center, but you notice wherever the juice was coming over, it did kill the grass, but we're collecting it all. And they have this strange device in here, but I didn't have a picture of it. Basically, there's a 4-inch pipe in here that goes to the storages. So that's their low flow collection. a screen box to keep this, the settable solids out. And you notice in this picture, these guys were pretty good bunk manager. Whoever was in charge of that bunk kept it pretty clean. That's good, because if they didn't, we'd have all kinds of solids down through here. But the high flow goes into an 8-inch pipe, and it's just a spreader pipe out here with 1-inch holes every 10 feet. So the high flow gets distributed on a grassed area down below there. And I walked down and looked at it. It was really pretty good looking. I was surprised. But even this farmer didn't like the fact that he had a 4-inch pipe going to his storage. When it was raining all day, and it wasn't raining hard, it would not fill up this box big enough to go out here, but he was collecting 4 inches, collect a lot more than 5 gallons a minute. That really bothered him. So that was a challenge. This is one I actually worked on years ago. This particular farmer, we got a phone call through the district, and he had built a brand new asphalt pad, 1 acre asphalt pad, and they were getting ready to fill it, or within a couple of weeks they were going to fill it, and we got, we didn't have any option, siting and whatever. It was a location, he'd always did bunk silage storage for years. So the pad was constructed in a hillside, and we put a bunch of different low flow collection boxes along the perimeter and one edge. And then I come up with, yes, a 10 by 50 tank just for my leachate. The idea was we were guessing 14,000 tons of silage would be piled in this one humongous pile. And we put this tank in there to give him some, I don't know if it's 30-day storage at this point in time, but a bunch of storage here so we could collect that juice for a significant number of days, because in the end, we didn't have the storage, the manure storage, if you could look in this picture, was across the valley. This was several thousand feet across the valley. So he had tankers. He was just going to tank this liquid and run it across the valley over and dump it into his big storage. I think they're milking 1,200 or 1,500 cows at a time. So we're going to take this leachate and dump it in the storage, get the dilution, and work from there. Well, what do you know? The first year they filled this thing, you can look at the pictures here, they overfilled the thing. They went beyond the pad with silage. And so we had juice that was going beyond my collection systems, and it was going down it was a disaster. But anyway, I did collect a lot of it a year. I think we put some new device in here to collect more of it. But here again, a grand plan, a great design, and they manage it a different way than we anticipated. But just a different way of collecting juice at a remote site and hauling it somewhere else. Example of a smaller site, the one on the right, on the bottom here was just under construction, just finished up. But here again, typical beautiful sunny day out, and here's your leachate coming out there, and we're collecting it in a low flow device. Yeah, I think my recollection was they had finished this part, but they hadn't finished seeding it up and whatnot during construction. And then, just typical, a small bunk situation. But this also allows the farmer to run in and out with his equipment to fill the bunk. That's the other challenge we're into. We want these settling areas, but they can't be too big, cause problems loading and unloading. That's always the other challenge. Another interesting one we did, we actually collected low flow and high flow in one collection box. So we had this depression to get our settling area in here, and then from there it actually went into a tank here with a pump in it, and then overflowed into 2 more tanks. So we had, I forget how many gallons, we had like 750 or 1,000 gallon storage in these 3 tanks. So high flow and low flow goes into here. But let's say it's a nice day, you get low flow coming in here, goes into tanks. What the farmer wanted to do was, he didn't have a waste storage facility to pump to. So our solution was, this is that first tank that you saw the lid from. So the solution was, they cut off the valve going to his distribution system, and he had a floating device here that went up and down. He would actually haul the juice for maybe a week or so. Everything that came into those 3 tanks, he would pump down every day or every couple days, so that he would haul that concentrated low flow and dilute it down with, he'd fill his tank with manure and top it off. He would haul it away and spread it because he had nowhere to go. He didn't have a waste storage facility, but he hauled manure every day. So during those 20 or 30 days a year when he filled that bunk silo complex, or that one bunk, he had to do this process. That was his simple high O&M method of solving the problem. Now, the second part of the story is, once that leachate quits running, you're still going to collect stormwater. And what we did was they put in a system called a flout. Who's heard of a flout? Anybody? It's a flow out device. It's like a automatic siphon system. But this one here, what happens is these 2 boxes, you can barely see them here, these boxes, when the water starts coming in, they actually float up. When they float up high enough, they are open-sided. water dumps over top, they drop down, and then they discharge. This one here is kind of cool. It has this control mechanism. So we have two flouts here with two pipes. So we have two discharge points that come out of the hillside here, and there's two pipes there, spreader pipe left, left system and a right system. So we have two spreader pipes that when this tank fills up during a rainfall event, or maybe rains a day or two, it takes a day or two to fill up. Once it does fill up, it doses to one side. The next time it fills up, it flips the other way and doses the other side. So we have more resting period between the dosing, especially when you don't have much rain or misty rain or whatever, you can dose it back and forth. So, but that's where the high flow goes. It also helps that we have 1,000 gallons in here, so even if we have 30 or 40 gallons of leachate, we get enough dilution so it doesn't kill the grass. But again, O&M from the farmer, he's got to haul that for 20 or 30 days. He's got to keep after it to haul that concentrated flow. If he doesn't do that, we'll come out next year and we'll have dead zones on both sides here. That's what will happen. Another example, large operation. The initial, coming off probably a 1 or 2 acre site, we put a settling basin in that's probably about 5 or 10% of the drainage area to settle out the floatables, multiple screens. Then it goes into, you can see in the background here, it goes into a temporary holding pond. They probably had it designed for a 25-year storm as a CAFO, so we had enough capacity in here to handle a 25-year storm. 5 or 6 inches of runoff on a 1 or 2 acre pad, that's a lot of water. And then from there, I think this one was gravity, but it's gravity flowed out, it might be pumped, but it's pumped to a spreader pipe. Now my preference would be if you have to pump it, instead of a spreader pipe system, I'd go to some vertical irrigation system. We have a lot better luck with those. They do a better job of distribution, let's put it that way. Either way, we're taking the high flow material and going out to a grassed area. An example I saw, it's probably been 10 years ago, back up in Vermont. We were actually there the day they were filling silo, but all the juice came off that, dropped into one drop box, came out here, and they had a big basin. They had a big storage basin here for settling out solids and whatever. I didn't see any solids in there, but it was a humongous basin. Then he had another control structure out here. Yeah, let's back up here. The low flow was, they had a pipe in here that captured low flow and went to the storage. But all the high flow went to this big basin, then went to this first basin, and then they had a secondary area. The discharge from that basin was a pipe underneath the stone here that kind of boiled up and flowed into a filter area. So they settled solids on one basin, went to a secondary basin, and that discharge was slowly metered out in this thing down through a filter area. Quite a convoluted method. And they like to use gravel. They wanted to bury this, they worried about freezing in the wintertime. And they also had another gravel channel halfway down the hill, so in case you had, it helped distribute it across the entire cross section. Just a little different way of doing things in Vermont. And they also had cases where they had a split VTA. Same thing, we were doing that siphoning system where you'd run one side for a couple months and flip it over and run the other side. That's always a good idea too if you have the space. That way you can, if this area gets inundated, you can still flip it over to the other side. This area dries out, you can harvest your materials off of here. If you have vegetative loss, you can reseed, and you still have a place to go. So always an advantage to have a split system if you can have that. I'm going to show you some engineering wonders of the world from the NRCS staff in different states. I think a lot of these are New York State, but certainly here we have a bunk complex system. At least one screen here to screen out the floatables, keep them from coming down in here. We have kind of a channel here, so the low flow is going out this pipe. Don't quite show it, they probably have a drop pipe here, but so the low flow goes out this way. When it starts raining hard, this pipe can't handle it. It comes out of this weir flow here and goes into a grassed area. So we're only collecting what goes through this pipe, and I don't show the drop in here. Maybe the next picture does show that. No. Just another example of all kinds of innovative methods to screen out and screen out the solids and go with that. Here's the most complicated and high-tech, I guess, one. The farmer didn't want to have to go down here and manually, these screens will plug up. Sometimes we have 2 or 3 screens. They only had one here. So he had just made up a skid loader, come down and pick this thing up, he could drag it backwards, drag all that crap out of there. Then he could take it, pick it up and shake it. Bring it back down and set it down. He didn't get out of the vehicle and shovel or do anything. But here's the real thing. So you have a pipe going through here, looks like maybe a 6 or 8 inch pipe here, and you notice there's a sleeve on here. That sleeve you can slide back and forth, but the idea is you got leachate coming, it dribbles out of that pipe, it drops into the low flow collection system, which could go to a tank and a pump or straight to storage. When it starts raining, you're going to get some flush here, but this pipe will actually start overshooting that and not go down this pipe. And then when it gets more than 5 or 6 inches deep here, the rest of it will flow out of here, or it'll all go to the high flow system, maybe 18-inch pipe, okay, 18-inch pipe here, and then it'll flow to maybe a pump system or to some sort of distribution system for your high flow. So you can get all kinds of interesting combination of things done. But, you know, back to the concept. We have a concept of what we want to do. We certainly think this is what should happen, but then we run into these situations where the farmer does what he does anyway. This particular guy had too much forage at one time, so he overtopped the whole system. You know, here we have the collection system, the pipe, and all this kind of stuff, so it would work. But we need to talk about O&M for a second. You know, tailored to every operation. Everyone's unique and different. You got to talk about moisture, right harvest conditions, proper covering, contingencies. You know, we want to document this. We're trying to control everything up to 25-year storm. That's our goal. Describe the daily monitoring and cleaning, address equipment failures. All those things need to be in the O&M. Really need to detail that up front with everybody. Secondary leachate. There is some systems out there where you can really put a nice collection system in and really minimize the amount of rainwater. Even if you have rainwater on top of it, it goes between the plastic and there, and you don't get that loss of dry matter in your silage, but you get less leachate, that percolate I talk about. You know, leachate is a concern. We hear about it in Pennsylvania all the time. We have 7,000 dairies. We get phone calls from DEP or landowners working with DEP on trying to resolve their issues. There's all kinds of ways to do it. It's a lot of unique situations. The design for every site's different. The best solution is if we could go to a farmer and say, hey, I'm going to build a bunk silo. Let's figure out where to site this. We love those situations. We have an opportunity to do it right the first time. And my one last comment, in the end, I said bunk guy, it's just bunk guy or girl, but whoever is filling up that TMR and running equipment on that site, that person has to buy into the O&M. They need to clean that little box up if there's solids in there, move that tire around, clean the screens, take the dirty material, put it somewhere else, do a good job of covering and uncovering. You know, that person can make or break the best design or the worst design you ever put together. So keep that in mind. And the last thing for references, we have if you go to the field office tech guide for Pennsylvania, under waste transfer, that's where we have silage leachate. We talk about some generalities in there. We don't get into specifics. And we actually have, if you go to the Pennsylvania NRCS site, under technical resources, engineering, design guides, we do have Design Guide 10, which is design guidance for silage leachate. So we have a whole procedure in there of sizing, settling area, transfer, and all that kind of stuff. It's a guideline because you got to tweak it for different sites, but that's where we keep our general criteria.